kilogram sec. And nowadays CGS is the name of the SI unit, Standard International Unit. So these are the systems, and we have to put some value, some unit for the force. So that is basically for FPS, and we pound weight, and per unit area. So that will be meter square area. For CGS, this is the mass, weight, or you can use even generally we use Newton, or you can use gram weight divided by the centimeters square. For M case, that is kg weight per meter square. So even the systems changes, if you know how it's coming, what the background, what is the story of that particular parameter, then it's not difficult to remember the units. And that's how I skipped the units before in the previous class to make it more defined way, and that will help you to keep this in mind and never forget. So pressure is very important factor for mostly for the gases, and for the liquid also. That is, sometimes we put in a container, and some also in the conduit pipelines. If the pressure increases, that generally bursts out. So that you have to be very careful. We have the forces trying to act over the pipelines, and you have all the liquids going in, and you have the more pressure being developed within the pipe, so there is chances of bursting out. So we'll talk about the burst things and all that will be in the more advanced part of this course. So pressure is important, and what we use to measure the pressure, that is pressure gauge. Okay, so what the pressure gauge does, it try to compare the pressure with the atmospheric one. So as I told that the atmospheric pressure that we generally take as a reference. So pressure gauge, you can have either the plug type with a spring, and that has the nozzle, the actual gas, and what is atmosphere. And nowadays we also have the digital. We also use the manometers, piezometers. That is nothing but you have the pipes, and you know from the balance of the pressure. So anywhere if it is the atmosphere, if it is gas, definitely it has to be a close one, otherwise it will spread out and nothing will happen yet. So if this is gas and some liquid is standing here, so we have to take the reference where both the limbs having the same pressure, and from there we have to find out the weight of the column, because that is the pressure it is acting on the reference level. So what is the composition of that column depending on the density and the circular area? So the total weight you have to balance, and from there you can understand that what could be the pressure here or here. So because sometimes pressure is too high. So we have the inbuilt pressure systems in the pipelines, and that has a circuit that generally sends the pressure at different intervals, and that transmit the real-time data to the control room for the pipelines, and we try to maintain this pressure, and if there's something happening, increasing or decreasing beyond the safe limit, we can just turn on or turn off the valves in the pipeline, and that helps to kind of have or to avoid any disaster. So pressure is a very important factor or parameter that we should measure, we should understand, and we should control by keeping the basics in mind, and that's here. So we have done the pressure, the PV equal to nRT. So pressure, volume, all are done. Mass mole, that is definitely more chemical properties of any fluid. The molar mass, that how much how gram or microgram definitely of the mass that can be contained in a single mole. So mole size depending on that. That we'll discuss later. For R, it is a universal gas constant for any substance, so that is 8.31. And then temperature. So temperature is another important factor that we discuss. Definitely the temperature won't be same, it is either increasing or decreasing. So depending on that, either P can change or V can change, because this equation has to be there. This is the universal gas equation that change its form. Studying about the temperature. That's basically a thermodynamic property of the fluid, and thermal energy, that is basically either going inside space or coming out. So depending on what the insulation you have around that container, because the thermal energy is everywhere there, it is coming from the sun, it is getting absorbed depending on the whatever substance it is also absorbed in the liquid or gases every time, because the sun rays come through the atmosphere. So more the gases can absorb the molecule sun radiation, the solar radiation, the more it will be heating up the atmosphere. So you know the greenhouse effect. So it is kind of glass wall, and when it's coming in, it has a shorter phase, and this glass is nothing but the atmosphere. But when it comes inside, hitting back on the surface, the wavelength increases. So when this wavelength increases, the property or the tendency of the gas molecule certain glass molecules that change and they absorb more. So that is basically if you have this CO2, methane, so that kind of, even the water vapor. So that basically absorb more heat when you have a longer radiation. So that does not interfere much with the shorter radiations that is incoming in solar. But OLR, the outgoing solar radiation, is getting absorbed by the CO2, CH4, water vapor, and some other greenhouse gases. This is the greenhouse gas. So this basically affects the how the temperature is contained within the atmosphere, and that actually happening very fast over last few decades, and it will going to increase, and that is all sort of kind of discussion we have nowadays about the climate change. And depending on that, how much atmosphere is getting heat, or the heat energy can be absorbed within that actually kind of supplying that energy to have more turbulence. How? Because turbulence is not a laminar thing, it has to be have an angular motion. So for the energy required for the linear to the angular motion, that is more, the particle movement is much more faster. And so when you contain the energy through the absorption, and you are actually cutting off the OLR, the outgoing radiation, is not only increasing the temperature over the land or over the ocean, but you are adding more energy to the particles that is in the atmosphere. So they start moving faster and faster. So more the movement, even nowadays, more with the kind of recession. So nowadays, what you can check over the internet, that the velocity of the hurricanes or the cyclones from the ocean to the inland, that has increased manifold. So nowadays, what is the formation of the cloud over a certain day area, and the next day or the same day itself, it can come over the land and having massive rainfall. So all because of this temperature, and temperature is imparting the energy, the extra energy within the particles. So more the energy you can contain, more will be the internal force within the atmosphere. The same thing, like if you are heating up any closed container and particles getting more energy, so definitely the pressure will be increased. Volume cannot increase because it's a fix, so pressure definitely will increase. And if it is beyond this holding what are the safe stable pressure of that particular container, so it can burst. The same concept is also applicable when you are talking about the heat within the container or the heat within the atmosphere. So all this comes to very same basics, and temperature is basically the change in thermal condition. That's how we can measure the temperature. So for FPS, generally we use Fahrenheit, for CGS the centigrade, and also for MKS it is mostly the centigrade. So to measure the temperature, we generally use some probes. We we can use a thermometer that having a liquid that is basically the mercury, and mercury as very much responsive to the temperature, so it very quickly can increase its volume and move to some or cover some more length in the tube, so it is easy to understand that what is a change in the temperature. So that's what we generally find out. It's not the absolute thing, it's a change. It's a change in the thermal condition. So that we have to keep in mind. And nowadays there are so many kind of probes are available that you can understand what the, even you can find out some pure metals that also can be used for understanding the temperature, because those are very responsive to the temperature. So that may be gold, that may be silver. So there are many more probes are available, and that can be used for measuring this parameter temperature. So with this, I'm trying to close out the measurements, units and dimension of the fluids. So basically, we'll talk more in the dimension factor, like what are the basic dimensions we have for different units and how that can be compared, and for solving a kind of condition or the equations, how that dimensions are useful for all of us. So that we'll discuss in some different classes. Okay, see you. Bye bye.